Guide them straight to the belt. We need to clear this section before the next batch arrives.
A commercial watermelon harvest operates in tons rather than pounds. During the peak season, a single facility must intake and sort millions of pounds of biomass daily, creating an immense physical load that must be moved through the factory. The water functions as a kinetic energy absorber. Its volume provides enough resistance to dampen the velocity, stopping the fruit's downward momentum before any single watermelon can collide with a hard surface. Buoyancy takes over as a passive sorting mechanism. As the dense fruit displaces the water, the fluid creates an upward force, perfectly balancing the downward mass. Scale that up, and this physical equilibrium turns unmanageable projectiles into a stable layer of weightless objects. Once the energy of the dump has dissipated, the pool reaches a serene state, with thousands of green rinds bobbing gently and reflecting the sunlight. The liquid cushion serves as a mechanical intermediary, converting a high-energy hazard into a stabilized holding field with zero risk of impact damage. While the water pool prevents damage, it lacks any directional organization. The watermelons are safe, but they have no momentum to move deeper into the factory. To give this disorganized mass a clear path, manual laborers are stationed directly within the pool environment to provide the necessary directional logic. Workers in high-visibility vests and rubber boots stand at the edge of the pool wielding 12-foot wooden poles. They reach into the water to gently push and untangle, separating dense, drifting clusters. Human spatial awareness allows these workers to identify potential jams and adjust their pressure on the fly, avoiding the bruising of an automated arm. Their objective is spatial. They must funnel the broad mass of floating fruit toward the narrow intake of the factory's automated pipeline. With a few precise nudges, workers steer the watermelons out of the open pool and into the strict single-file line required by the conveyor belt. This manual effort provides the transition point between the fluid physics of the pool and the rigid automation of the factory belt. The watermelon completes its journey, evolving from a high-velocity freefall into an orderly mechanical procession in just a few minutes. This entire pipeline relies on a hybrid design that integrates mechanical force, fluid dynamics, and human labor into a single continuous system. This hybrid approach offers a clear advantage. Compared to dry sorting belts, a water flume system allows a massive increase in fruit volume moving three interdependent pillars: brute mechanical power, the science of fluid dynamics, and precise human intervention. High-volume industrial efficiency is achieved by engineering environments where heavy machinery, physics, and human judgment can work together to manage a high-speed harvest.